In this fifth video of JavaScript function series, I will discuss the arrow function and IIFE, which is immediately invoked function expression. We will learn to write these different type of functions and understand their differences and suitability. I start with arrow functions. As the name suggests, we use an arrow to define an arrow function. And here's a simple definition of an arrow function. Here I've written an arrow function with a console.log statement. So if I have to pass any argument to this function, I mention these in the parenthesis. The arrow indicates the start of the function and the body is enclosed in the curly braces. Now, since this is an expression, I use a variable greet to store the definition and execute this function using the variable name. Now, there are a few things that I want to talk about arrow functions. So, when we define an arrow function with only one statement, we can omit the curly braces. The second arrow function, greet1, is similar to the first one with one console.log statement and no curly braces. When we define an arrow function with only one expression, we again can omit the curly braces and the function implicitly returns the result. In this example, there are no curly braces and the function of implicitly returning a value is evident from the console.log statement, which displays the result. And when we define an arrow function with a single expression and multiple parameters, again we can omit the curly braces and it implicitly returns an output. An arrow function with multiple statements or expressions must have the curly braces and an optional return statement. Now we will see how an arrow function works with this object. An arrow function, unlike a normal function, has no access to this object. So in this example, when we display the value of this, it shows an empty object. An arrow function, just like a normal function, forms a closure. It captures the lexical scope and remembers the variables from the surrounding context. Let's understand this with the help of an example. I start by defining a function with a local variable message. Now this function returns an arrow function, and this arrow function now has access to the variable message of the outer function and displays its value. Here is another example that shows an arrow function lexically binds this object as well. I write a function that returns an arrow function. Now this arrow function displays this object. Now since this object is lexically bound, it shows the global object. If you recall, I wrote an arrow function named using this a few minutes back that displayed a blank value for this object because an arrow function has no access to this object. Another thing about an arrow function is that it does not have its own arguments object. However, I can compensate for this using the rest operator. What if you mention arguments in the console.log statement in an arrow function? Well, in this case, the arguments object differs greatly from what we see in a regular function. So be aware of it and have a look at the output. By the way, when you write a console.log statement with arguments in a script, outside a function, you will again see the same output. With this, I conclude arrow functions. Let's summarize what we have learned so far. Now we will talk about IIFE. It's immediately invoked function expression. An IIFE is a function that executes immediately after its definition. A common purpose of using this function is to create a new scope that does not pollute the global scope and limits the scope of functions and variables. To define an IIFE, we start with the parenthesis, and the function is defined within these parentheses. Right after the definition, we add another set of parentheses. Now, this second set is used to execute the function expression, and this happens immediately without writing the function name explicitly. Just like a normal function, it is possible to pass one or more parameters to an IIFE, and these are mentioned in the second parenthesis. An IIFE, just like a normal function, can also return a value. An IIFE has its own arguments object, which it can use to handle an unknown number of arguments. An IIFE can access this object just like any other normal function. An IIFE can use the closure feature just like a normal function. So when an IIFE executes, it remembers its lexical scope and accesses the variables defined in the outer scope. This allows the creation of private variables and functions. In this example, I write an IIFE that declares a local variable, message, and it returns an object with two functions. Now, once the IIFE executes, I get a reference of the object, which I can use to manipulate the values of the variable message. With this, I conclude IIFE, and let's summarize what we have learned so far. JavaScript offers different type of functions for different programming needs. Now, these types provide developers with some flexibility in how they can write and use these functions. So far, we have learned about function declarations, function expressions, arrow function, and IIFE. Now, in this section, we will summarize how these functions differ from each other, how methods like call, bind, and apply affect this object, and finally, how these functions can be used in practical situations. We start with the comparison of syntax. Now, for a function declaration, this is the most common way to define a named function. So, we name it at the time of its definition and we use this name to execute the function. Now, function expression, as the name suggests, is defined as an expression. We can assign a variable to this expression, and once a variable is assigned, we can use it just like a normal function. If we do not assign this function a variable, it is an anonymous function. An arrow function is also an expression, and we use an arrow to define this type of function. It has a shorter syntax than a normal function. And finally, the IIFE. It is also a function expression that executes immediately after its definition, and it executes only once. Now we will discuss closure, and all the four type of functions have closure support. And when we talk about closure, it means we have two functions interacting with each other. We call these inner and the outer function. So the inner function is defined within the boundary of the outer function, and the outer function returns a reference of the inner function so that we can use the inner function. Whenever we have this type of situation, JavaScript creates a closure, and the inner function can access its environment, which means the variables and the parameters of the outer function, even after the execution of the outer function is complete. And JavaScript maintains this enclosure until we maintain a reference of the inner function. Let's have a look at the example. In this code snippet, the function log template is an outer function that accepts one parameter. The return function statement within the function is an inner function, and the outer function returns a reference to this inner function. While doing so, JavaScript creates a closure where it maintains the prefix parameter available to the inner function when executed. Next, I execute the outer function with the parameter info and store the reference in the variable info logger. Now I execute this inner function and pass a message as a parameter. Now, due to the closure feature, I have access to both the message and prefix and can print the message. Now is the turn of hoisting. Now, function declarations are hoisted. Function expressions, arrow functions, and IIFE do not support hoisting. Hoisting is a feature of JavaScript that moves the function declaration to the top of the respective scope during the compilation phase. Now, this allows to use a function before it is defined in the code. And if a function is not hoisted, it is not possible to use it before it is defined in the code. In this code snippet, the function test hoisting is a function declaration. So it is possible to refer to this function before it is defined as JavaScript hoists this function. But in the case of function test hoisting again, since it is a function expression, JavaScript does not hoist it. So it is not possible to refer it before it is defined. And in this case, JavaScript throws a reference error. Here I will discuss the arguments objects that JavaScript provides. It is available for all type of functions except an arrow function. When a function is called with a variable number of arguments, except for an arrow function, the arguments object receives all these arguments. Now it is an array-like structure that allows access to argument value using indices, and it is not possible to access this object outside the function scope. However, using the rest operator is now recommended instead of using an arguments object. Now, this is a very interesting point to discuss. In JavaScript, this is an object, and the value of this object depends on how a function is called. So, in a standalone function declaration or a function expression or an IIFE, it represents a global object. In case of browsers, it is a Windows object. So in the code snippet, I have defined three different types of functions, and these functions display the value of this object, which is same for all the three type of functions. Now, in case of a standalone arrow function, this represents a blank object. And when we define an arrow function within another function, the arrow function lexically binds this object from the surrounding context. So in the code snippet, the first function is a standalone arrow function that outputs a blank object. However, in the second function, the arrow function lexically binds this object, and hence it displays a similar output as we saw in the last example. Now we will see how methods like call, bind, and apply change this object's behavior. So when we use any of these three methods, we can pass an object to a function, and this object represents the object we pass to the function. So with the call method, we can pass an object to a function and it executes the function immediately. If a function expects more arguments, then we can pass these arguments individually. In the case of apply method, again we can pass an object to a function and it executes the function immediately. The only difference is that the arguments that a function expects must be passed as a single array. In this code snippet, I define a greet function. Now the console.log statement refers to this .name. Now to execute the greet function, I use a call method and pass an object as a first argument, which is represented by this object. This is followed by the remaining arguments a function expects. And this statement executes the function and displays the value. In the greet.apply method, here too I pass the object as a first argument, and the apply method executes the function immediately. The only difference is any additional arguments to pass are combined in one single array. With the bind method, we pass an object as a first argument and the remaining arguments are passed individually. It does not execute the function immediately. Rather, it creates a new function which we can capture in a variable and execute using the variable name as and when needed. So in the code snippet, the new function reference is captured in a variable, and this variable is used to execute the function. And with this, I come to the last topic of this video, which is sharing the use cases of these four different type of functions. We start with the function declaration, which is a very good choice when we need a named function in our application. A clear name makes it easy to understand the function's intent. Or when we want to use a function throughout the application lifecycle and from different scopes of the application, there also a function declaration makes a good choice. And this makes a function highly reusable and easy to maintain. Another use case is when we wish to use recursion. A named function is the best choice because it is possible for a function to call itself before it is defined only through a function declaration. When it comes to function expressions, we prefer function expressions when we want to create an anonymous function that we wish to use only once or pass as an argument to a function or assign to a variable. It is also a good choice to use a function expression when we want to define a function on the fly based on some program logic or runtime conditions. Generally, we use these functions as a callback or event handlers in web development. Let's have a look at the few use cases. In the first example, I create a function expression that adds two numbers, and I store the reference of this function expression in a variable for future use. In the second example, we will see how we can pass a function expression as a parameter to a function. So for this, I write a calculator function that accepts three parameters. The first parameter refers to a function. This is the calculation we intend to do by calling this function, and pass the remaining two parameters to this function. So in the first instance, I define a function expression add and pass it to the calculator function. And in the second instance, I have defined an anonymous function as a first parameter of the calculator function. So this is an example of an anonymous function, and I cannot use it anywhere else, just like an add function. Moreover, I also want to emphasize that I have to read the function body to understand its purpose. And when we pass an anonymous function as a parameter, we should keep it short for clear understanding. The third example is of conditional creation. So if a particular condition is true, we create a function with one particular logic. Otherwise, we create a function with some other logic, and we execute the code according to the flow of the application. Now we will talk about arrow functions. We've already seen in the beginning that arrow functions have a shorter syntax, and a single line function is sufficient to do a simple calculation as compared to a function declaration. And just like function expressions, we use arrow functions as an arguments to a function, event handlers, and callback function. Now these functions lexically bind this from the surrounding environment, and the following example explains this in more detail. Here I've defined an object num counter. Now this object has one attribute value and three methods, which is get value, decrement, and increment. We will use these three methods to manage the value attribute of the object. So first is the get value, which we have defined as a function expression. A function expression, when we use in an object, it binds this object with the object itself, which means I can refer to any attribute or method of the num counter object using this dot notation. So I can refer to value as this dot value. The second method of the object, decrement, is an arrow function. Now remember, an arrow function does not have its own this object. So it will not be able to bind the attributes of the num counter object. So the statement to decrement the value will not work, although it will not throw an error. So we should avoid using an arrow function as an object method. The third method shows how we can lexically bind this object with an arrow function. So we start by creating a function expression which binds this object to the num counter object. Now I define an arrow function within this function expression. Now this arrow function lexically binds this object of the function expression, which represents the num counter object. Now, due to this lexical binding, the arrow function has access to the value attribute and can increment the value of this attribute. When I execute the code, the increment method, which is a function expression, increments the value by 1. But in the case of decrement method, where I've used an arrow function, there is no effect on the value variable and it throws no error either. Now the last topic, IIFE. An IIFE executes immediately after the definition. This is useful when you want to create a private scope and prevent name collisions. We can use this for initialization activity that we do not wish to expose, or when we need one instance of an object. In the first example, the IIFE creates one variable and an object with two methods, show message and update message. The function returns the object with two methods, which allows me to manipulate the value of the variable message. Now this variable is visible within the context of two methods. Thanks to the closure feature, this keeps the global environment free when a variable has a limited visibility. In the second example, we can use an IIFE to initialize an application. This too can help in keeping the initialization code away from the application logic. In the final example, I'm showing how we can use an IIFE to create a single instance of an object. So in this example, the IIFE initializes a counter and returns an object, and I can use its methods to manipulate the value variable. This is very similar to the first example which I showed few minutes back. Now since IIFE executes only once, I will get one instance of the counter. And we can use this style to create a single instance of an object in our applications. With this, I conclude this video. Thank you for watching. If it has helped you, please like it and feel free to comment. If this video can help any of your friends, please share it with them. And subscribe to this channel so that you don't miss any videos in future. Thank you very much. Keep learning.